Well, hi there, boys and girls. Today we're going to look at two different forms of a derivative, but they still find a derivative. These forms are going to find a derivative at a specific point. They both do the same thing, but there's just two different forms. They're both the same process. They're a limiting value on a difference quotient. This first one is the limit as x approaches a of f of x minus f of a over x minus a will give you the derivative of a function at a specific point a. It will go ahead and it's just going to give you a number. It'll be the slope at that point. F of x is the function you're dealing with. A is the x value where we're actually calculating the derivative. There's another version, which is f of a plus h minus f of a over h. This will also find f prime of a. I'm going to show you how to interpret these in question form. We're also going to look at differentiability. Differentiability is the ability to find a derivative. We cannot always calculate a derivative because of, well, three limiting circumstances. And those are, first of all, the function must be continuous, or we may not take a derivative. Also, at the point we're trying to find the derivative, we cannot have any vertical tangent lines. If you remember from geometry or algebra 1, if your slope is vertical, what is the slope? I'm sorry, if your line is vertical, what is your slope? If you have a vertical line, then that slope is undefined. And since derivative means slope, if we have a vertical line, we cannot have a derivative there. The last thing is what's called a teetering tangent line. We cannot have any sharp turns, and I'll show you why that is in a minute. So let's go ahead and look at some examples. Here's the first example asking us for a limit, and we can see that is in the form f of a plus h minus f of a all over h. So that's that second form. This is going to give you f prime at a. So we have to find two things. First of all, what is the point a, and what is f of x? So the first thing we should look at is what is happening to a plus h. Here is a plus h, and what is happening to that? Well, it's being cubed. So f of x would have to be the cubed function, or x cubed. And a is pretty easy to find. It's right there, and it's also right there. Here's f of a plus h minus f of a, where a is 4. It's been thrown into the x cubed function, so a is 4. So in order to answer this, we are going to say that f of x is x cubed, which means that f prime of x is 3x squared. So f prime at 4 would be 3 times 4 squared, which is 3 times 16, which is 48. Let's look at another example. This is f of a plus h minus f of a over h. And here is your a plus h. And what is happening to your a plus h? That's how you're going to find your function. Well, it is being thrown into the square root function. We're taking the square root of a plus h and the square root of a. So that's how you figure out your function. And the a value, where we're trying to find the derivative, is fairly simple. It's just this number right here or this number right here, and that's obviously 9. So we are trying to find the derivative of the square root of x at the value 9. So if f of x is the square root of x, then we know that f prime of x is 1 over 2 square roots of x. Again, that's because that can be written as x to the 1/2. Then you go through your power rule, and that's how you get this derivative. Now we plug in 9, and we get 1 over 2 square roots of 9, which is 1 over 6. Let's take a look at the other form. Here is also the definition of a derivative at a point a, but this is in the form f of x minus f of a over x minus a. Here, f of x is very easy to see. F of x is the very first term in your difference quotient, so we know automatically the function we're dealing with is the square root of x function. And a is down here on the bottom. Now, why is this top number a 2? This top number is a 2 because this is f of a. In other words, we throw a, which is 4, into our function, and the square root of 4 is 2. So this is what's happened after you've thrown the value a into your function. This is f of a. So it's easier to find a, or the x value, by looking in the denominator. So we want to find the derivative of f of x at the value 4. So we know that f prime of x is 1 over 2 square roots of x. So f prime at 4 is 1 over 2 square roots of 4, which is 1/4, which is right here. All right, let's take a look at this derivative stuff. Remember, on differentiability, we said we can't have any vertical tangent lines. It's got to be continuous, and we can't have any sharp turns. So here we have a function f shown below. Which of the following are true for f on the open interval a to c? Let's go ahead and go through here. The domain of the derivative of f is the open interval a to c. This means that you're able to take the derivative everywhere between a and c, not including the endpoint a or c. Remember, parentheses means we're not including a or c. So let's look. From a to c, can I take the derivative everywhere between those points? Well, everything's fine here because it's continuous, there's no sharp turns, no vertical tangent lines. However, this right here is a sharp turn. What is the derivative there? This is what I call the teetering tangent line. Is the derivative 0? Is the derivative positive 1 as you come from the right? Is it negative 1 as you come from the left? See, it's like this teetering tangent line. Because the slopes from the right and left don't match, you may not take the derivative at this sharp turn. So this is not differentiable. Even though it's continuous, we cannot find a unique derivative at that point. So Roman numeral 1 is a false statement. Because of point B, there is a sharp turn. Okay, what about f is continuous on the open interval from a to c? Well, yes, it's continuous because there are no gaps and there are no holes. We can draw that picture without lifting our pencil between a and c. That is a true statement. Roman numeral 3, the derivative of f is positive on the open interval from a to c. Well, that's clearly incorrect because the derivative is negative from a all the way down to and not including b. It doesn't start to become positive slopes until b to c. So that is not a true statement. So my answer to this is 2 only. All right, last question. We're going to estimate. My tables went off the page here. We're going to make our own little table. X, f prime of x at a, b, and c. Let's take a look at this x value a. Go down here. This is a sharp turn. This function is not differentiable because of the teetering tangent line. So my derivative does not exist. At b, this is like a little shark fin. I've got from the left, I've got some positive slopes, but then immediately it turns to negative slopes. Teetering tangent line, I don't know what the unique derivative is there. Therefore, it's also a sharp turn. Cannot find a derivative at b. At c, we can find a derivative. We can actually even approximate it. At c, it's some value that's negative. I'll say -2 or -1. It doesn't matter. So there's our table. And again, I'm sorry, my tables, you can see, went off the page. So that is the 2 alternative forms of the derivative, and that's also differentiability. And that concludes our set of topics before we take our next quiz on Tuesday. All right, well, I will see you guys tomorrow.